Hi, and welcome to our lesson on simplifying radicals, or sometimes referred to as simplifying square roots. But again, as we learned in our last lesson, anything that is inside of what is typically known as a square root symbol, the square root symbol is also known as a radical, and inside are our radicands. Now, there's three things we need to check to make sure radicals are simplified. So, radicals are simplified when they meet these three criteria. First off, there cannot be a perfect square factor inside the radical, which we'll look at, but factors meaning something that can be divided by a perfect square. And your typical perfect square list would be over here. It goes longer, but perfect squares are numbers that when we apply a square root, they equal a whole number or a non-decimal. So for example, the square root of 4 is 2. Square root of 9, 3. 16, 4. 25, 5. 36, 6. And so on. So our perfect squares are numbers that when we apply a square root equal a whole number or non-decimal. So when we're simplifying, we want to what we call factor out or divide out our perfect squares. The second condition is no fractions inside the radical. So we'll go through how to get rid of those, but we cannot have any fractions inside of the square root. And then the third criteria is no radical in the denominator. So if we are dealing with a fraction, we cannot have a radical or a square root on bottom. And again, we'll look at how to solve or take care of that situation. So we're going to move on down to these two properties that we're looking at. And these properties should be pretty familiar based on our properties of exponents as well. The product property means if we have two values being multiplied inside of a square root, we can split them. So an example of that would be if we have 4 times 9 inside a square root, which is the square root of 36, we could split that to the square root of 4 times the square root of 9, which is 2 times 3, which is also 6. So the product property allows us to split the inside by dividing it into two pieces, or different factors. The quotient property says if we have a fraction inside of a radical, we can split the numerator and denominator and separate the radical. So if we had, for example here, square root of 16 over 64, we could solve that as normal, which would be 4 over 8, or 1/2. Or we can split it, square root of 16 over square root of 64. Square root of 16 is 4, square root of 64 is 8, and that equals 1/2. So these properties are what allow us to simplify different radical setups. So example 1 asks us to simplify each radical expression. So again, for each one of these, we're going to check these three criteria. So we're checking for perfect squares, checking for no fractions inside radicals, and again, no radical in the denominator. So in A, we just have the square root of 27. So what I want to think about is 27 a perfect square? No, it's not. But can 27 be split into factors that include a perfect square? Yes, it can. 9 times 3 is 27. So we can split the square root of 27 into the square root of 9 times the square root of 3. The square root of 9 is 3. Square root of 3 can't be simplified without it being a decimal. So our simplified answer to the square root of 27 is 3 square roots of 3. In B, we have 5 times the square root of 12. So I'm going to separate out the 5, and then the square root of 12, we want to think about a perfect square factor, which would be 4. So the square root of 12 becomes square root of 4 times the square root of 3. The square root of 4 is 2. Square root of 3 just remains. So our simplified answer is 10 square roots of 3. In 32, the square root of, or in C, I should say, the square root of 32 can be split to the square root of 16 and the square root of 2. 16 being our perfect square becomes 4. Square root of 16 is 4. And the square root of 2 is not a perfect square, so that just stays square root of 2. So our simplified answer would be 4 square roots of 2. In D, now we have inside the radical 108. So again, you want to try to think of a perfect square that can be divided out. In this case, it would be 9 and 12. 12's not a perfect square, but 9 is. So that would become 2 times the square root of 9 times the square root of 12. But the square root of 12 can be broken to the square root of 4 times square root of 3. So the square root of 4 is 2. So our problem actually becomes 2 times 3 times 2 times the square root of 3. Or 12 square roots of the 3. In E, we're going to apply our quotient property. Because we have a fraction inside the square root, what we can do is split the top and bottom. Square root of 5 over square root of 16. Now we want to check top and bottom for perfect squares. 16 is a perfect square. Square root of 16 is 4. So our answer is square root of 5 over 4. We do not have a radical in the denominator, and the radical on top only goes to 5. So we are simplified and we're good to go. In F, square root of 54 over 3. So I'm going to look for perfect square factors on top, 9 being a factor. So we have the square root of 9 times the square root of 6. Square root of 9 is 3. So then we would have 3 times the square root of 6 over 3. We can cancel the 3's. So the 3's here cancel. And we should have a final answer, which I forgot to write here, of square root 6. So our final answer there would be just the square root of 6, because our 3's there cancel out. And we're left with just square root of 6 over 1, which is square root of 6. All right, moving down. In G. So G, H, and I. In G, we have a fraction inside a radical. So we want to split top and bottom, square root of 48 over square root of 75. Then we want to look for perfect square factors. So for 48, it's 16 times 3. For 75, it's 25 times 3. 16 and 25 are perfect squares. So when we simplify top and bottom, 4 square root of 3 over 5 square root of 3. The square roots of 3 cancel, so we are left with just 4 over 5. In H, we want to split top and bottom again. So square root of 48 over square root of 81. Check for perfect squares, which the bottom, square root of 81, is a perfect square of 9. And the top, 16 times 3. So square root of 16 becomes 4. So we'd have 4 square roots of 3 over 9. And then in I, want to split top and bottom again. square root of 90 over square root of 160. Divide out our perfect squares. So square root of 9 times square root of 10 on top, square root of 16 times square root of 10 on bottom. The square roots of 10s cancel. Square root of 9 is 3, square root of 16 is 4, so our answer is 3 over 4. Now, example 2, this type of set here, asks us to multiply the radicals, then simplify. So in this case, if we have a radical times a radical, square root of 3 times square root of 12, that simply becomes the square root of 36. Then we can apply a perfect square. Square root of 36 gives us a final answer of 6. In B, we have square root of 6 times square root of 15. 6 times 15 is 90. So the square root of 90 can be simplified by dividing out the perfect square of 9. So square root of 9 times square root of 10. Square root of 9 is 3, so we get 3 square roots of 10. And in C, 4 square roots of 5 times 2 square roots of 10. So what you want to do is the numbers out in front, 4 times 2 give us 8. Square root of 5 times square root of 10 is the square root of 50. So then the square root of 50 can be divided to 25 times 2. So 8 times the square root of 25 times square root of 2 is 8 times 5 times square root of 2, or 40 square roots of 2. And now in example 3. In example 3, we are going to look at the idea of rationalizing the denominator, which is that third rule from the beginning of our notes, where we cannot have a square root or a radical in the denominator. So rationalizing the denominator means no square root or no radical in the denominator. So how do we get rid of a square root on bottom? So if we have a square root in our denominator, so if our problem is 5 over square roots of 3, to get rid of that, you multiply top and bottom by that radical. So if square root of 3 is on bottom, we'll multiply top and bottom by square root of 3. On top, that just becomes 5 times the square root of 3. On bottom, square root of 3 times square root of 3 is just 3. So our final simplified answer would be 5 square roots of 3 over 3. In B, we first have to split top and bottom, so we have square root of 4 over the square root of 13. Square root of 4 is 2, so we have 2 over the square root of 13. Now to get rid of the square root of 13 on bottom, we have to multiply top and bottom by the square root of 13. So the top becomes 2 square roots of 13, and the bottom is just 13. In C, 30 over square root of 18. So again, multiply top and bottom by square root of 18 to get rid of the square root on bottom. So we have 30 square root of 18 over 18. 30 and 18 can both be divided by 6, so that becomes 5 and 3. So we have 5 square roots of 18 over 3. The square root of 18 has the perfect square 9 in it, so we're going to split that to 5 times the square root of 9 times square root of 2. Square root of 9 is 3, so we have 5 times 3 times square root of 2 over 3. The 3's cancel out, so our final answer is just 5 square roots of 2. And then our last few examples. In D, again, top and bottom are both going to get split. Square root of 20 over square root of 63. Now, I want to look for perfect square factors. So on bottom, perfect square factor would be 9. So square root of 63 can become square root of 9 square roots of 7. The top is still square root of 20. So square root of 20 over 3 square roots of 7. Then before I worry about anything else, I could also factor the top. It adds the perfect square of 4, which becomes 2. So now my answer is 2 square roots of 5 over 3 square roots of 7. I have to get rid of the square root of 7 from the bottom. So both top and bottom get multiplied by square roots of 7. So the top becomes 2 square roots of 5 times square root of 7. And the bottom is just 3 times 7. So we get 2 square roots of 35 over 21. In E, we want to multiply top and bottom by square root of 15 to get rid of that on bottom first. So we have 2 square roots of 45, 3 times 15, over 15. Check to simplify square roots of 45, so the perfect square 9. So 2 square roots of 9 square roots of 5. Square root of 9 is 3. So we have 2 times 3 times square root of 5 over 15. 3 and 15 can both be divided by 3. So that simplifies to 1 over 5. So on top we have 2 square roots of 5, and on bottom we have 5. And then our last example, F, we have square root of 6 over 3 square roots of 2. So we're going to multiply top and bottom by square root of 2, and we get the square root of 12 over 6. Because on bottom, square root of 2 times square root of 2 is 2. 2 times 3 is 6. Then factor the top. Square root of 4 times square root of 3 becomes 2 square roots of 3 over 6. 2 and 6 can be simplified to 1 over 3. So our final answer would just be the square root of 3 over 3.